friends, students, enthusiasts. One more project in our kitty. So today we have taken a LoRa project. That is also based on IoT. So we'll discuss about this project. What is this project? So first of all, the name. The LoRa-based smart agriculture monitoring and irrigation control system using ESP32. So please remember there are two parts over here, as you can see in the diagram here down below. One side we have used Arduino board, and other side we have used ESP32. So Arduino board becomes the transmitter part, that is the supporting component with the help of LoRa, and the receiver part is ESP32 with the help of LoRa again of the same frequency. That is, EX and RX frequency should be similar. But it is 433. The receiver should also have 433. If it is having different frequency, then it should have different frequency. All right. So this is the project. A small schematic diagram, not exactly schematic diagram, a pictorial diagram. Not exact, but it is already given. Okay. So let's go to the next part. That is what it actually objective is. So once again, I will tell you, we can name this project as LoRa-based smart agricultural system. Precision farming with long-range wireless sensor network. What do you mean by long range? That means the Wi-Fi range, the Bluetooth range, it is more than that, LoRa range. Okay, so that is the objective. So objective, no monitors to monitor soil and environmental parameters or long distance. So soil, temperature, humidity, or related to soil, whatever the parameters are that we can monitor, and we can view it or we can send it to a long distance that is up to 10 kilometers. Of course, we can send more than that depending upon the antenna and the module and the power we're using for the LoRa. So, and automatically control irrigation. That means we can control irrigation, that is switch on off of the motor and viewing whether your irrigation is required from a longer distance. While sending data to a central gateway and web dashboard for farmers. Central gateway means if you are using a cloud computing where a farming is it is centralized, then you have to use central gateway. But here we have used a web dashboard for farmers. That means the farmer is the important person who can look after his farm and he can control the motor. So application part where we use it, precision farming, large agricultural lands, remote villages, smart irrigation system, and smart farming schemes, government smart farming or other smart farming schemes where we can use it. Okay, so I have made a small block diagram. I'll just try to explain you. So here in the block diagram, there are two parts. One is transmitter part and one is the receiver. So according to my project, I have used two sensors here, sensor 1 and sensor 2. Sensor 1 is of soil moisture and sensor 2 is temperature and humidity. It can be of the soil, it can be of the atmosphere. That is connected to Arduino. Power supply will give power to both, that is to the sensor as well as to the Arduino. And from Arduino, again, the LoRa gateway is connected, that is LoRa module is connected. Okay, and it will be communicating with the Arduino and the this thing, that is whatever the sensor parameters are there, it will be giving it to output as a transmission to the from the LoRa. Same time, this side we have a relay also which will control the irrigation motor. And for just for the local display, we have used an OLED display on that side, which will also give you the complete parameters of sensor 1 and sensor 2. And also the condition of the relay, that is whether it is off or whether it is on. Right. So this is a transmission part, and the secondary is the receiver part. So receiver part, LoRa gateway RX is there, which will receive the signals. It will be giving it to the ESP32, which is the main board for IoT purpose we have used here. And it will drive if the temperature or this is more, it will also give you an indication, that is we have kept the threshold value over here, and also it will show it on your web dashboard. So this is about the block diagram part. Now let's go to the parts, what we have used. So there are two fields. I told you that is TX and RX. So in one part we have used Arduino. You can use Mini also, you can use Nano also. Then LoRa for SX1278, you can use any model. But please remember, the module should be, in our country, whatever module is permitted, that is whatever frequency is permitted, that module only you have to use it. So it can be 433, 868, or 915 megahertz. Then you have to use a captive soil moisture sensor. Then you can use DST22 or DST11. And battery, that is for the power, or solar panel, that also you can use it as a solar panel. Because in farming, if it is a long distance, my idea is you can make it with the solar. So you have to only add solar panel and the regulator and proper batteries for it. The second part is gateway nodes, that is the receiver part. So ESP32, as we have already discussed, one more module of the same frequency, that is SX1278 of any of the frequency which is used in the country. Then you have relay or module. Sorry, the relay module has been used in the sensor node part, that is this side, and the Arduino part we have connected, and we need only Wi-Fi connection on the other side. But please remember here, without Wi-Fi also we can do it. I have done it without Wi-Fi. I don't require a Wi-Fi. So these are the parts pictures. You can see the different pictures of the components what we need, right? Okay, so these are the connection diagram, pin diagram, that is SX1278 to Arduino. I've given the diagram, that is where to what is to be connected. Then soil moisture sensor are to Arduino, how it is to be connected, that is A0, and DST11, it is connected to D4 of the Arduino. Relay module I have connected from D7 of the Arduino, and OLED, again I'm telling you, I've used an OLED also. So now SSD1306, that is connected to A4 and A5. Now coming to the receiver part, that is receiver part. The components are very less, only ESP32 and LoRa module, SX1278 to the ESP32 connection. So connections are being given here. Please remember one important part, LoRa module will work only with 3.3 volts. So you have to remember, you should not increase the voltage, or you should be very careful with giving the connection. I have also used an LED, that is GPI, which is connected to 25, pin number 25. So these are the connection which I have already used. Now, checklist as the connection goes on, that is 433 megahertz TX and RX, both the sides. LoRa powered at 3.3 volts. That's now I told you. Antenna connected. Please remember both the side. If you want a distance, or if you don't want a distance, even you should have a small antenna connected on the LoRa. That is TX and RX. Any type of antenna can be connected. For that, you can go to my old videos where I've given you why it is important. And DIO 0 connection should be connected properly. Open browser. Now I've told you that you don't need a Wi-Fi. So you have to open a browser, but with the IP address of 192.168.4.1, and you have to run it. Okay, that is the main part. Okay, then what is the final project features? OLED display will be showing the field units. Automatic irrigation will be shown. Long range LoRa communication. Please remember, long range. We are using LoRa. We can do it with Wi-Fi and other things, but I've used LoRa. Then ESP32 web dashboard will be shown to the farmer, which will be helping the farmers. LED pump indicator. So here one LED is also being used, which will give you whether the pump is on. Okay, so it is mobile friendly. Why? Because we are not using a Wi-Fi connection. So let's go to our lab and check our project. In our lab now. So as you can see on your screen. So I'll just explain you what are the connection, then I will show you the display. So here, first part, that is the transmitter part. So this is my Arduino board. You can see on the left hand side, this is my Arduino board. I will try to zoom it. Okay. So this is my Arduino board. Okay. So Arduino board, these are two my sensors. These are two sensors. One is a temperature and humidity, and another one is for soil moisture. The soil moisture, towards this thing, I have put it here in the soil. You can see here the soil, and these are the sensors which I have kept it here. So this will go into the soil, which will take the sensor reading, right? Like you can see it, and this is my main module, that is my transmitter module or LoRa module. So LoRa module connected with antenna. It's just simple type of wire, which is as it works as an antenna. And this is a relay. So I was having a dual relay, but I need only single relay for one relay only. And other side of the relay, I have connected the pump motor. Okay. So this is the arrangement on one side. Please remember, power supply, I'm giving it from the batteries. That is a 7.5 volt totally rechargeable cells. I've used 17805 regulator IC over here. And from there, I have given connection to all these things. So this part is working with battery. Okay. You can, instead of battery, you can use a solar power also. And you can use. So you can see on the display. I'll try to show you. I will try to zoom it and I will try to show you to you what is coming on the display. So as you can see, it is on the display. I'm getting temperature, that is on the local side. That is this part. What I'm trying to show you will be on this side. That is your local part in a farm side. So you can see here 30 degrees temperature, humidity, and soil moisture is showing. And pump is off position. When the pump gets on, then only the other things, parameters will go to other side. Okay. So these are the display side. So that's what I wanted to show you. Okay. So now what is other side? I will just try to show you. So pins configuration and all I have already shown you, and other side I will try to show. So this is also other side. That means this is my ESP32. Okay, this is my receiver side of a LoRa, and I have used a simple one LED. That is when the motor start, then only the LED will come. Okay, when the moisture level, we can give a threshold values also. One the moisture level. So this side I've used this thing. Again, that side I've used one small antenna. That is, this is my antenna. You can see spiral type of antenna is there. So any antenna will do, because this is a nearby. So if you are making it for a bigger project, like you want to show it to you, your this thing, then it has to be on the other side. Okay, please remember that. Okay. So we were discussing. So how the connection has been given, that already I will be sharing with you. So receiver side, only the components are very less. This is your ESP32 board. How the connection, that is already I am going to share. This is one LED that is giving the indication whether the motor is on or off. And this is my LoRa receiver communication. So this part I'm just driving it with the help of the supply, which is coming from my laptop. So this part I'm giving it through my laptop part. Okay. So I will just show you the web part. That means when you connect, when this will work, that means when the sensor values will come from transmitter to the receiver part, then how you are going to check it on the web. That means the farmer, how they are going to check whether the motor is running and what is the temperature of the soil or the atmosphere there. That part is important. So that I'm going to show it to you now. So I will tell you how you are going to watch it on the web, that is on your mobile phone, on your laptop or your computer. So you have to go to the tools first. Okay, on the tools you have to check Wi-Fi, go to Wi-Fi, and there is, you can see, refresh it, and you can see what are the networks. So we have kept it our network as smartphone. So just connect it, connect to your smartphone, this thing, and password is will be given. So password is whatever the password is given. So in my case it is the 1 2 3 4 5 6 7 8. Okay, and we just take it. It gets connected. So smartphone is it has come over here. So this is, you understood. Okay. Now, as you can see, the codes for transmitter side, that is LoRa transmitter side, where we have used Arduino. So these are the libraries that you have to go in the beginning, and the connection what we have given. This is very simple. This is all these details I will be sharing with you. So for the display and for the temperature and humidity, which is to be sent from through LoRa, so that we have given it here. So this is for the display, and the baud rate here we have kept it as 9600. Okay, so this is your transmitter codes. The receiver side, that is ESP32 codes. So in the beginning, this 4 are the libraries, that is LoRa-H, serial, then a web server and Wi-Fi. Pin number definition, we have to connect to these pins and all. That is what we have taken it there, exactly same configuration that is on the transmitter side. So we are taking all these things, and here the baud rate is approximately 11.5200. Okay, and please remember one more important point is here. We are using Wi-Fi AP format. Okay, so Wi-Fi AP format we have to give our smartphone, and the passcode is 12345678. So you can change it and you can just define it over here. So this is the only thing, and all the details whatever you have given, the LoRa 433 megahertz there and here, it should be same. And all the pump motor is there. This from here the HTML page starts. That means for displaying it on your web browser, and it will be directly for getting refreshed every time. So this is your this is the codes, and you will be getting this thing on serial monitor also. The information. I hope you will like this project. If you like it, please share with your friends. If you want more knowledge of this thing, please write in the comments. Thanks for watching. See you next time.